Okay, welcome to today's lesson. In this video, I'll be teaching you mole and how to calculate the mole of a substance. So first of all, what is mole? Mole. Mole is the amount of substance that contains the same number of atoms in exactly 12 grams of carbon-12. It is the amount of substance. The mole of a substance is the amount of substance that contains the same number of atoms in exactly 12 grams of carbon-12. So 12 grams of carbon-12 is used as a standard in determining the mole of a substance. So again, the mole of a substance can be defined as the amount of substance that contains the same number of atoms in exactly 12 grams of carbon-12. This is the simple definition of the mole of a substance. The number of atoms in 1 mole of a substance is 6.02 times 10 raised to the power of 23. This is the amount, or this is the number of atoms in 1 mole of a substance. And this number 6.02 times 10 raised to the power 23 is known as the Avogadro's number. So in other words, 1 mole of a substance is equal to Avogadro's number, which is equivalent to 6.02 times 10 raised to the power of 23 atoms. 1 mole of a substance is equal to 6.02 times 10 raised to the power 23 atoms. And we're going to see this in our calculation. So from formula, we have that mole is equal to reacting mass all over molar mass. Mole is equal to reacting mass over molar mass. So let's look at an example here. What is the mass of 3 moles of oxygen, O2, given that the relative atomic mass of oxygen is 16? What is the mass of 3 moles of oxygen? So in this question, we are given that the number of moles of oxygen, let's put the solution here. We are given that the number of moles of oxygen, mole, is equal to what? 3. What is the mass of 3 moles of oxygen? So we are looking for the mass, because the question is, what is the mass? The mass of 3 moles of oxygen. So the mass is unknown. Then the molar mass of oxygen is what? Molar mass. The molar mass of oxygen is the relative molecular mass of oxygen. So the relative atomic mass of oxygen is 16. Molar mass of oxygen, O2, is equal to what? The relative molecular mass of oxygen is 16 times the number of atoms in this oxygen molecule, which is 2, times this 2 times 2, and that will give us 32. So having fished out these parameters from the question, we can now say that mole, from our formula, mole is equal to reacting mass, which is the mass, reacting mass, over the molar mass, over molar mass. So we are given that the number of moles of oxygen in this question is 3. So 3 is equal to, let's put a line here, 3 is equal to the mass, which is the reacting mass, over the molar mass. The molar mass of oxygen, O2, is 16 times 2, which is 32, over 32. So this is the same thing as 3 all over 1. 3 divided by 1 will still give us 3, is equal to mass, which is the reacting mass, over 32. So if we cross multiply, mass times 1 will still give us mass. So the mass, which is the reacting mass, is equal to 3 times 32. And that is equal to 96 grams. Mass is measured in grams. This is our answer to this particular question. So the major thing here is to remember what mole is. Mole is equal to reacting mass over molar mass. That is a simple formula for calculating the mole of a substance. Let's look at the next example that we have here. The second example is, how many grams are in 2 moles of sodium chloride? How many grams are in 2 moles of sodium chloride? Given that the relative atomic mass of sodium is 23 and the relative atomic mass of chlorine is 35.5. So we are calculating the grams. How many grams are in 2 moles of sodium chloride? So the number of moles we are given, mole is equal to what? 2 moles of sodium chloride. 2 moles. Then the mass is unknown. The mass is measured in grams, so it is unknown. Then the molar mass of sodium chloride, molar mass of sodium chloride is equal to what? Is equal to 23, which is the mass of sodium, plus 35.5, which is the relative atomic mass of chlorine, plus 35.5, and that will be equal to 58.5. So this is the molar mass of sodium chloride. We just have to sum the relative atomic mass of the two elements. Sodium is 23, chlorine is 35.5 from the question. So, having done this, we can now write out our formula. So what is the formula that relates these three parameters? The formula is mole is equal to mass, which is reacting mass, over the molar mass, over molar mass. So from the question, we are given that there are 2 moles of sodium chloride. 2 moles of sodium chloride. So we write there 2 is equal to mass, which is what we are looking for, over the molar mass of sodium chloride. The molar mass of sodium chloride is 58.5. 58.5. So this is the same thing as 2 over 1. 2 over 1 will still give us 2 is equal to mass, the reacting mass, over 58.5. So mass times 1 will still give us mass. Here we cross multiply. Mass times 1 will still give us mass. So mass will be equal to 2 times 58.5. So 2 times 58.5 will be equal to 117 grams. So this is the answer to this question. So if you look at this question, the question is how many grams are in 2 moles of sodium chloride? How many grams? So how many grams is also referring to the mass, because mass is measured in grams. I hope you get that. So let's look at the last example that we have in this lesson. The last example is how many moles are present in 44 grams of carbon dioxide? How many moles are present in 44 grams of carbon dioxide? So the question is how many moles? How many moles? So our mole will be equal to unknown. It's not known. That is what we're looking for. How many moles are present in 44 grams of carbon dioxide? So the mass in question, the reacting mass, is equal to 44 grams of carbon dioxide. Then the molar mass of carbon dioxide, the molar mass of carbon dioxide, CO2, will be equal to what? The relative atomic mass of carbon, C, is equal to 12. Oxygen is equal to 16 times the number of oxygen atoms that I have here, which is 2 times 2. That will be equal to 32. So therefore, the molar mass of carbon dioxide, CO2, will be equal to 12 plus 32, and that will be equal to 44. 44. 12 plus 32 will give us 44. So having done that, the next thing we want to do is to write out our formula. That mole, the formula of mole is equal to reacting mass over molar mass. Reacting mass over molar mass. So the mole is what we are looking for. The question is how many moles are present in 44 grams of carbon dioxide, given that the relative atomic mass of carbon is 12 and the relative atomic mass of oxygen is 16. So we're looking for the moles. So mole is equal to our mass here. The reacting mass in this question is 44 grams. How many moles are present in 44 grams of carbon dioxide? So this is the mass in question in this particular example. So our mass is 44 grams, our reacting mass is 44 grams over the molar mass. The molar mass we've calculated here is 44. That's the relative molecular mass of carbon dioxide, 44. So over 44. So 44 divided by 44 will give us 1. 1 here, 1. So 1 divided by 1 is 1. So mole, the number of moles that are present in 44 grams of carbon dioxide is equal to 1 mole. This is our answer to this particular question. This is actually very easy, very simple, and straightforward. Thank you so much for listening. See you in our next lesson.